Okay, so hello and welcome back to another Unity tutorial. In this video we're going to be getting into mocking, which is a part of unit testing. Unit testing, I've done a video on it about a month ago and the link's down below, so if you want to go watch that first if you're not familiar with what unit testing is, and then come back here. So mocking, following on from that, is when you unit test your code, sometimes it's super simple and you can just write a test. But sometimes the things you're testing, the classes you're testing, actually have dependencies, and you can't really easily fill in those dependencies. You can perhaps make like a test class and pass that in as your dependency, but then you'll have to just make loads of files all over the place for like test this, dummy that. It's a bit silly, like it just makes more files, more like junk clutter everywhere. It makes much more sense to use what's called a mocking library, and I'm using MOQ mock. It's spelled mock with a Q, and then there's also others like End Substitute, and I'm sure there's plenty more. These are just the two that I'm familiar with. So I'm going to show you how to set up and install mock. You could just get it through the package manager inside Visual Studio, but the problem is Unity won't recognize that and it has some problems with it. It's all weird. So I'm going to show you how to do it like the proper way so that Unity gets along with Visual Studio, and then I'll get into an example of mocking. So yeah, hope you enjoy the video. But of course, first I've got to thank my patrons, so special thanks to Flow State Games, Average Morning, Art Farrell, Buddha Ray, Remy Baldwin, and Phil Baum. If anyone else is able to help support the channel monetarily, the link to my Patreon will be down below. If not, there are also links down below to my social media. If you could go follow me on all those, it would be greatly appreciated. Now let's get to the video. Okay, so step one is to install and set up mock. So step one is get a project. I'm using the solid project from the last few videos, so if you want to get this, it's on my GitHub, otherwise just bring up a project you have. Make sure you go to Window and Package Manager. And I've obviously removed all the packages I wasn't going to use for this project, but there are some that you'll need for mocking and unit testing and stuff. So if you go onto all and make sure you got preview on, just in case we do use a preview package, but we probably won't. Just scroll down here, and there's a few that you need. So you're going to need anything pretty much to do with testing. So I mean, it'd be nice. Oh no, there is a search thing actually. I forgot about that. You're going to need the test framework. So install the test framework, and that gives you access to the test runner, which is where you run your tests, pretty obvious. And then, to be honest, after the test framework, I don't think there's anything else we need from the package manager, but we'll go ahead to Google, and I'll link all these down below. This is the actual, package itself, mock. So I want you to go and click on download package, and then you get a zip file there. I've got WinRAR, but anyway, it's not zip, it's a nugget package or whatever. But regardless, you can open it with any like zip file editor, and this has a dependency. It has two. Using .NET Framework 4.5, you need Castle Core, greater version, or and system tasks extensions. Not or, you need both, okay? I've got them both open here, and this one has no dependencies for this, so I can just download this one. And then on the other end, we have this system threading thing, which has a dependency on that one, so we're going to just download this, and then we're going to go to that final one. I've already got it open here, I think. Yeah. And then from here, it has no dependencies, so we can just download that one. So those are the four NuGet packages there. So I'm going to close, back to Unity. The test framework is installed. Now, if we go to our window and go to General Test Runner, and we go drag the test runner on the side, you'll see here it is. It says create an edit mode test assembly folder. So I'm going to click create and call it tests. So in my root, I've got a tests folder. And inside there, we've got this ASMDEF, which is the tag for or the extension for an assembly definitions file. It basically tells you what other code to include in stuff within this directory of code. So currently, it uses the end unit framework, which is to do with the testing, and then the test runner here. What we want to do is we want to go to where all our game code is and create an assembly definition file. There it is. And we're going to call it. I usually just call it game logic. It really doesn't matter what you call it, to be honest. Just make it, sensible. And once you've created that, it'll do a little bit of compiling. Then up here, you'll see all this stuff. And to be honest, you don't need to mess with that. You can just leave that as it is. And then over here in the tests one, remember, your game code logic doesn't need to have access to your tests. It's the other way around. Your tests need access to your game logic. So if I go over here and I click add, and then in this third empty box now I go and find game logic. Now, any test code I write has access to the code in my game logic folder, so that makes sense, or in my scripts folder where I put the game logic assembly definition file. Now, until you actually write any tests, it's going to give you some problems or whatever. So inside this test folder, we want to create another folder called, actually no we don't, sorry, we'll just put our tests in here, but before we make a test, we want to actually import the mock stuff. So if I go to my downloads folder, where am I going? here we are. We've got the 4 things here. So let's make a folder in our root called plugins, and a folder for mock. And inside the mock folder, we want to put in all the things from these packages. So we want to open this up in Explorer because it's much easier to work with. Go inside the mock folder. Okay, and then from there, we want to open the mock thing in, I'm opening it in WinRAR, but it's up to you to whatever you open it in. And I'm going to go into the lib folder, net45, which is the version we're using, and drag across the mock DLL. And then that's that first one done. Then we go up to the next one. Doesn't really matter what order you do it in. Go away WinRAR. Okay, lib 45, castle core in. Close that one. The next one, lib, go away WinRAR, lib. And then on here you have to use net standard 2.0. That's just for some reason that's what you have to do. And then drag that in, close that. And then finally, this runtime one, lib, standard 2.0, drag that in. Okay, so now we can close this. You can delete these from your downloads folder, whatever you want to do. They're all in the Unity thing now. Here they are. And that'll compile. And now you've got access to that package. It's quite simple. You actually have to do one last thing though, which is go to, well when you, this isn't, I'm not sure if this is necessary, but it seems to have some problems otherwise. If you go to your other settings, just make sure that your API compatibility is net 4.0 times something, because the packages we use are from that version. So that'll just do a little compile as well. And finally, if you go to your tests, ASM assembly definition file, you need to add one more DLL, which is the mock DLL, which is right there. You don't need to add the others, because it's the mock one that uses the others, so you don't need to actually say to use the others, okay? Now in here, we can start writing tests. So let's just go to the test folder and write a new test. So C# script, and we'll call it mover tests, right? So this is what you would do if you're testing a certain unit or class or thing. You'd open that up. Now I'm just going to skip ahead to when Visual Studio's open. Okay, so here's the mover class, but we actually want to change it to be a non-mono behavior, and I'm going to put it inside a tests namespace. That's not necessary, but I'm just going to do it anyway. Just put that inside here. Now, there's one thing to note, which is game objects and mono behaviors are like awkward to test with, because yes, you can create a new game object in a scene and add components to it through here, but it gets very awkward because, you know, mono behaviors are just special and weird and whatever. But what you actually want to do, ideally, is refactor your code to just use normal classes wherever possible, because it's so much easier to test a normal class than to test a mono behavior class. So what we're actually going to do for the sake of this is we're going to take, I'm just thinking some people are going to be using this project to learn for the dependency injection, so I don't really want to mess this up too bad. So I'm actually just going to go and create a script specifically for this so that we don't mess any of that up. I'll be back in a minute. Okay, I've set up a class. I've made a separate folder called mocking. I should probably rename this to mocking mover or whatever. And basically the mocking mover is just a normal class that has a speed that's sent in on creation, the transform it's meant to move, on creation, and also the input getter, which is what we're going to mock. Because we're going to pass through an actual transform, because that's the concrete implementation we want to move, right? In the game, whenever you move, you're always moving a transform component, so that's fine to be concrete. But the movement input getter could vary, right? We just set all those things on creation, and then we have a move function we're going to have to call externally, which does the normal movement code, but it moves it on that transform. So this class is what we're testing, right? So we're going to, in here, say test, okay? Now this would be for normal tests, but the problem is it's not really a normal test because it's happening over time. So we have to use a Unity test, like so, not that import. And then from there, we need to make a public enumerator, because it's a coroutine happening over time, like so. And then from there, it's writing the name of the function, which is essentially the name of the test. So I'm going to call it, for example, moving transform underscore moves correctly. All right, I didn't really have time here to sit and think of a good name, but that's the name of our test, right? So what we're going to do is we're going to have to create a new game object. So var mover or var transform, I don't know, equals new game object, right? So this will create a new game object in the scene. We'll just call it game object like that. Okay, so there's our game object. Then we want to add a component, right? Game object dot add component, and we want to add. Actually, no, we don't. Sorry, we're not adding anything to it. We're just using it as a transform to check its position. So I'm gonna say dot transform. Okay, so we cache the transform here. Makes sense. And then after that, we want to create a new instance of our mocking mover. So new mocking mover. Okay. We've got our mocking mover, and that needs to take in 3 different things, right? It needs to take in a speed. So let's just pass the speed in as 1. So that means 1 unit per second. And then we want to pass in the transform to move, which is game object, or we'll now call it transform. Makes sense because we've changed it to be its transform. And then we need to pass in an I movement input getter. Okay, well there's the problem because, well, it's not really a problem, but we need to now, pass in one of those, and it's like normally we'd have to create a special class for testing this to know what input to get. But what we can use here is a mock, right? So if we say var input getter equals new mock, right? And then if I import MOQ, now we have to pass in what type. So it's an I movement. I have to type this out properly now. I movement input getter. Okay. And then you can actually say dot object there just to get the actual thing of it. And then we pass that in there. So we're now passing in a mocked version of that. Now that might seem pretty pointless at the moment, but you'll see in a second why that's good. So we're going to cache that. So we've now got our mover. And we want to call dot move on it. Let me make sure the move is public. Yeah, okay, cool. So what we want to now test is if we put in a specific set of input, we should be at a specific position, right? Okay, so after creating the mover, we need to essentially wait 1 frame and then check if we've moved the correct distance. So we want to say yield return null, which skips a frame, and then we come back here, and then what we want to do is we want to say assert.r equal, and we need to pass in the position we're at and the expected position. So the position we're at is the transform.position, and we want to check if that's equal to where we expect to be. So it'll be a new vector 3, new vector 3, and we need to say, well, if we're moving, we're going to decide where we're moving, right? So the moving transform horizontal. Okay, let's change this test to be a horizontal test. So we're going to say get the transform whatever, get the object, pass that all in. That speeds at 1, and we expect to move a certain amount in the frame. Our end position on the X should be technically wherever. Well, let's call move first. So actually, wait, do we even need to do a coroutine for this? We'll say mover dot move. If it's over 1 frame, I guess we technically don't need to use a coroutine, but if you wanted to do it over multiple frames, you would. So let's actually just put that as a public void with a test before it. Cannot be an iterable block because I think it means because we got that. Yeah, okay. Create the mover, move once, and then check if our position is equal to. All right, let's mock the horizontal and vertical, or in this case just the horizontal, right? Horizontal is x, so we can say it's going to be x and then something, well, 0 0, because we're not moving on the x and y, on the y and z, sorry. Now this object we need to actually just store the mock, input mock, okay, and then this is input getter mock dot object, and we want to now tell the input mock, so input getter mock dot horizontal, dot returns set. Dot setup. What am I doing? All right, so on setup we want to say x dot horizontal. Okay, so when we try and access the horizontal component from this, we're gonna say returns, and then what's our horizontal value? Well, we'll say 1. Okay, so we're trying to move in the horizontal by 1. So now technically after 1 frame we're expecting to have moved. If we go back and look at our mocking mover, you'll see the actual amount we move is our speed, which is 1 times by time.delta time. So if our speed is 1, and then we should be at time.delta times worth of movement. That might sound odd to you, but I think that makes sense. So if we go back and check the test runner and fix. Okay, there's a compilation error, so just remove that. It'll then give me that. The type or what? Namespace mocking mover cannot be found. Wait, I don't know why it's letting me use that. That's a bit odd, isn't it? Mocking, it's in mocking. Did I not put it in a namespace? Namespace solid dot mocking. Whoops, that's not right. Where did I put the class head thing? Okay, everyone's happy, all good. Go back, import solid.mocking, and then make sure, well not make sure, but check if Unity's happy now. Unity seems pretty happy to me. It's got one test, and we run the test, and we pass. We actually, well wait, you go in here, it asserted that this position and this vector are the same value, which is good because now we've tested that we move on the horizontal correctly. So now we don't even have to check in our manual code that we move the correct amount over a frame, because we know here, and then like let's say I passed in, for example, 2 speed, and technically we should be at 2 times by, I didn't mean to press play. If I run it again, it's going to be wrong because as you see here, we expect it to be at 0.2, but we were at 0.1. You see the problem? We went actually twice as far as we were expected to be, which makes sense because we put the speed to be 2. So one cool thing you can actually do here just to make sure that it's in variable of speed. Okay, so the thing I was looking for was test case, so it's test case, and then from there you can pass in the parameters as arguments. So I can pass in 1f, for example, as a parameter, and then maybe I go for like, you know, 100f, and then maybe even I could go for test case minus and then a big number, right? For example, of speeds, right? So then here, when the input should still be 1, and then this here should be the speed, and then this should be times dot delta times speed. Now what you can do here is that means you can test this case, test this thing for multiple different values automatically, right? So here it's saying, oh, it passes for all these different values, because maybe you'll have a test that passes for certain input values, but certain different input values it doesn't work. Now you could write as many of these as you want, it's up to you. Put in weird and wacky values. You know, maybe try one of them as like, you know, 61.7 or something. Like just to put like a float in and a negative number. Like, you know, it all works. It's all good, right? All these things, they move correctly. Cool. So now we've tested that, and then maybe you also want to test, for example, horizontal, just to make sure that works. So that would be the same test, but instead, no, sorry, you use vertical here, and then vertical is obviously, well, okay, so vertical is on the z-axis in our game, remember? Because it's, you know, your character moving, you're not moving up and down. So just put that time to delta time in there, and change this to be vertical. So now I've written another test for making sure vertical works. I might as well use the same parameters, why not? And that one works too. So we pass all our tests, and now we are sure we have just run automatic tests to make sure that our character moves correctly based on input. And we've mocked the input here, right? So you could change this to be moving on both axes, right? So let's just do one final test. Moving transform, both axes moves correctly. So we've got the speed here. And we're going to say, let's copy this. So we've got vertical and horizontal. Now let's say, for example, just as a test, the vertical we move down, but on the horizontal we move up. Now I've got to remember that this is actually, if we try and move, it's normalized. The vector's normalized, right? So technically, we should normalize the, oh, let me think, actually. It should really just be 0.5, I think. So there should be time.delta time, but it's because it's, I'm moving negative on the vertical, there should be minus that times speed divided by 2. Because, as I said, minus that. Okay, and then it should be that for the horizontal. So it's the time.time times the speed. We're going positively, but it needs to be half that, because if we're moving forwards and right, we're meant to move at like half for both of them. Obviously we got a problem here because I probably did something wrong. Okay, so to make this work, we're going to have to pass through 1 and -1 instead of the time.delta time. And then once it's normalized, we then want to times by speed, or well, time.delta time. Doesn't really matter what times by first. Times by speed. Okay. And then the problem is with this one, right? Because we're doing normalization and stuff like that, it actually rounds. So we should just, to not get any errors that aren't actually true, because keep in mind, we just care we move correctly. If, you know, we're at the wrong x value by 0.000 something because it's rounded wrong, then it's not really a problem. So let's just pass through no parameters for this one, and then speed is just 1f, and then speed is just 1f. So don't have to multiply there, obviously. Cool. Let's go run it to test, to make sure our final test works. Why does it keep popping open on my screen? I have no idea. But anyway, it passes. Cool. So now we've actually managed to use mocking in 3 different scenarios. Obviously, it's the same kind of thing. But you get the point, right? You need an interface, but you don't care what it actually does. You just want to fake the return values, you know? Without anyone actually gaining input, you've just said, oh yeah, the return values are this, right? So that's how you use a mocking library. I hope you guys understand and, you know, make use of this. If you have any more questions, feel free to test them below. If you haven't already left a like and subscribe, it would mean a lot. But I hope you guys enjoyed this video. Thanks for watching. I'll see you in the next one. Peace.